So in this video, we're going to explore the concept of API testing around a constraint of CRUD: create, read, update, and delete. So just to reiterate, what does CRUD stand for? So we've got CRUD. So it's create, where we initiate some sort of event that creates something in this system. Create a new file, create a new user, create a new person, whatever. At some point, we're going to ask the system to return the information it knows about that. We're going to read the information in the system. We're going to update. So we're going to change something, initiate a change event. And we're going to delete, which is also a change event, to get rid of something from the system. Now, the reason this is important is that you should only be able to read something that you've already created. You should only be able to update something that you've already created, and chances are that you can read that you have access to. You should only be able to delete something that you've created. There's a sense of permissions in here, but really what we're looking at is we're looking at an entity life history. So a thing is created, a thing is read, it's accessed by people, it exists in a permanent form for some period of time. We can update it, we can change it, and we can delete it to remove it so it's no longer accessible. So let's start exploring the concept of entities. So basic life history. So I've got an entity, and the entity will be an item. So this item has a life history. I can create it, I can read it, I can update it, and I can delete it. Now what this diagram is really telling me that all I can do here is for each item, create it, then read it, then update it, then delete it. But clearly a life history is more complicated than that. It's a little bit more complex than that. So what makes it more complicated is that we have a sequence in the middle here, which usually repeats, where we are essentially living. I'm just going to put this living. It could be called active or something like that. But essentially what we have is we have an item which is created. Then over the course of its existence, we can read it, or we can choose to update it, and at some point we can delete it. Don't know how in the future this deletion happens. May never happen. Maybe it lives there forever. But we can't do anything. We can't really read or update or delete before we create it. So a model like this gives us a chance to explore state. I can see that there is a dependency in the state. In order to read something, I have to create it. In order to update it, I must have created it. In order to delete it, I must have created it. I don't necessarily need to have read or updated something before I delete it. So this asterisk here just means 0 to many actions. I can do this many times, or I can choose not to do it at all, but I can't delete unless I've created. So you can see the scope for testing in here, because with testing, I would want to go, well, can I delete it before I've created it? What happens if I do? I can only delete once here according to this diagram, so I'm going to try and delete more than once. I'm going to create something, then delete it again. I'm going to try and delete something that doesn't exist. And obviously there are other states in here. When I create something, the creation may not actually work. I may try and create it with invalid data, so the creation can fail. So each one of these steps, although it says the creation will happen, is not necessarily true. I will try to create, but I might fail. So I'm going to explore all the different conditions under which I can create before jumping into the living state. So this state may not actually transition into that state. So there's a lot of combinations in here and complexity just from exploring these simple states. So in terms of API testing, people very often associate create, read, update, and delete with specific verbs with an API. So create, they might map it onto a post. Read would be a get. Update might be a put. And delete will map onto a delete. And as soon as people have that mapping in their head, they then start to map it onto endpoints. So we might try and get all the items in the system. We might try and get a specific item in the system. So that'd be item number 1. We would post 2 items. Then we try and delete a specific item. But we're not going to do that. We are going to focus our energy over here with the entity life history, because all of this is actually the how. This is how we would implement the particular ideas that we're getting from the create, read, update, and delete mapping onto an entity life history model. What we want is the what are we going to do? We're going to create something. Why are we going to do it? Because it's part of that entity life history exploration. So we're going to stay over in this logical world, and that's going to constrain our testing. If we start approaching everything from a CRUD model just in terms of an endpoint and verb model, there's not really a lot of difference here between just normal functional testing with an endpoint list, where we get something on an endpoint, we post it because that's what you say, we just do normal verb coverage, we might do status code coverage, and there's no real need for that CRUD mapping. The CRUD mapping doesn't really help us here. But the CRUD mapping does help us with the entity life history model, because that's where it really makes sense. The entity life history model really gives us the what and why of what we're trying to do. So with an entity life history model, we can approach it on the basis of just path coverage. I could just do a create and a delete because this is 0 or more. I could do a create, read, delete. I could do a create, read, update, delete. I could do a create, update, delete. I could do a create, read, update, delete. I could do create, update, delete. Like, I could just go through the different combinations and have coverage. That would give me coverage of the life history. As I do that, the way that would help my testing is not necessarily the coverage. The coverage is fine. It will explore a whole bunch of conditions. But what I need to be conscious of is observing the output from each one of these actions to make sure that it is what I expect. To use that observation to guide my next entry point. Because with each one of these sequences, what I really have is I have an input, process, output, action sequence going on. So in order to create, I have to have some input, which is going to be a particular payload, particular verb, which is going to get processed by the system, which is going to return some sort of response. Because remember, we're testing through an API. We'll use a tool to do this. So I can vary the input that I'm going to get. The processing should vary automatically based on that input and based on the state that we already have. If I'm trying to update something that I have not created, then the state would trigger a different processing because it doesn't exist. And then I have to make sure that the output is what I expect. So I'm not just using this CRUD path and approach in order to drive my testing. What I'm doing is I'm basing my testing on the concepts of CRUD, but I'm conscious that I'm using an API and I must observe it in order to have the observations feed into my testing to make sense. Because what we're really focusing on is the variation. What I'm looking for is a difference in the input that makes a difference in the processing, that makes a difference in the output that leads to information, right? What do we want? We want information, and we will get it by hook or by crook by making sure that we pass in enough variation in the input, enough variation in the state of the entity, enough variation in the sequence of actions that we go through in order to observe something that leads to information that we can pass on that is useful to our project. That's really what testing is for. Okay, so let me get rid of all this junk down here. Okay, now when a lot of people are talking about API testing and they're exploring how we would test, at this point they would immediately jump into a sequence of let's create lots of test cases. So I'm going to, for each one of those sequences that we had, where I'm going to create, then I'm going to create a test case. Create an item with, we're not going to do that. Right, what we're going to do is we're going to list down the conditions that we're thinking of. We can think in advance before we test. That's perfectly fine. But I'm not going to turn those into cases. I'm going to turn those into ideas and concepts that I'm going to use to help me base my testing on, to provide it with some constraints. But during my testing session, I'm going to learn things and I'm going to change and I'm going to add new ideas in there. Some of those ideas I will follow up immediately. Some of those ideas I will not. I will leave them on the side and pick them up later because I'm constraining my testing. And in this case, I'm constraining it with the concept of an entity life history and the concept of CRUD. So for create, what could I do? Well, we've already mentioned that I can create something that's invalid, or rather I can't create something that's invalid. I can create something that's valid, and then I expect it to be in the system, and then I should be able to read it and update and delete it after that. So what would make something valid? Well, if it has all the mandatory fields. What would make something invalid? If it doesn't have all the mandatory fields. So the concept of mandatoriness at a field level is going to help me explore the invalid and valid conditions in there. What else might we have? Well, I know that an input is going to have some sort of fields. So we've got field types and values. I can explore that during the creation. I can also explore mandatory and field types in the update process, because presumably I should only be able to update it when these things are true. When we're updating, we have something slightly different as well, because we can try and amend field types. Perhaps I can move it from a string to an integer. Don't know. We'll have to explore this, but update has a slightly different set of behaviors than a create. Create is a one-off. Could I create over an existing entity? If I can, then it's an update, but it's a slightly different type of update. But I don't know yet, right? Because we haven't started testing. So I don't know where my testing is going to go. So I'm not going to come up with a complete list of things I'm going to do. But I am thinking through, what does creation mean? What does read mean? How could read change with an API? Well, I know that I've got accept headers. Perhaps I can use different accept headers and read it in different ways. Perhaps I can read it as JSON. Perhaps I can read it as XML. I don't know. I don't know what the API supports yet. We haven't done any API testing. We haven't looked at the API yet. At this point, everything is very logical. And I'm just coming up with ideas that I might use. So I don't want to do this process too far, because I don't know what's valid in conjunction with the API. One other thing, it's very important to realize with the entities approach that I'm using here. I've mentioned that I'm using it to constrain my testing. What I mean by that is I'm going to focus purely on a single item at a time, right? Create an item, update an item, delete an item that exists, delete an item that does not exist. I'm not really thinking about exploring the number of items or the state between items, because I don't have any other entity that leads me to think in that way. If I added the concept of a database, or what would be a logical representative, a repository. Now, a repository has a relationship with the item because, well, we could have multiple of these. We could have many items in a repository, which makes me start thinking, well, what are the limits? Are there any limits on this? Is there a maximum amount of items I can put in here? I would need to start exploring this relationship, but I don't have that concept in here. So I'm not going to be focused on the numbers. So I'm constraining the ideas that I have based on the model that I'm basing my testing on. During the course of my testing, if I see anything that makes me think, I really need to do this, so I really need to introduce this entity into my testing model, then I can choose to do that in that session if I want, change the scope, or I might need a different session in order to add that extra entity into my model. Similarly, I have no concept of user, but I could add a concept of user in here. So multiple people are in the repository, multiple people are accessing this, which then leads to a whole new set of conditions that I'm not going to explore in my current testing. What happens if multiple users try and access the same item at the same time? What if two people try to update it at the same time? How many users can the repository handle? Are there any permissions? Can user 1 access something created by user 2? None of that is in my current model, so I'm not going to explore that in this session. But you can see that I am fully aware of the possibilities in here. I'm just choosing not to incorporate that in my testing yet. That is not in the model that I'm basing my testing on now. So I'm constraining my testing, and that's what allows me to do exploratory testing in smaller sessions, because I try to constrain the testing, keep note of any ideas that I have, and add them in later. So I guess I should make a distinction at this point between some terms that we hear. So we often hear a term called model-driven testing and model-based testing. Now, both of these are very often used in the context of automated execution or automated generation of execution paths. Model-driven to me means everything is entirely driven by the model. You wouldn't do anything at all outside of the model because the model is driving the coverage that we're achieving. So this would be a pure automated approach. Unfortunately, in the world of testing, we tend to use model-based testing to cover what I just described. So model-based testing is very often used for we create a model, then we drive all the coverage that we achieve from that, and we call it model-based. But really it's model-driven. Model-based is what we as humans do. We create models, we base our testing on it. We do not allow ourselves to be controlled by the model. We do not allow ourselves to be dictated to by the model. We are not driven by the model. We base our testing on the model. We choose to interpret in different ways. And it's that choice that is allowing us to constrain it. We are not constrained because we are forced to work with a particular model. That's not what we're doing. So I think of my testing as model-based, even though that's not the way we tend to use that term in our industry. And this is the model that I'm basing my testing on. But of course, it's not going to be just this because we haven't yet looked at the API at all. So the first thing I'm going to do is I'm going to look at the API documentation. I'm going to use the simple API at apichallenges.eviltester.com, and we have documentation for this. I can see here that the content type header is used to define the payload, and this can be JSON or it can be XML. So I have some immediate variation that I can apply in the content type. So when I'm creating, I can pass in a payload that is JSON or a payload that is XML. When I'm updating, I can pass in a payload that is JSON or XML. I wonder then if I can switch between those headers. I can vary those headers. Maybe I can create using JSON. Maybe I can update using XML. Maybe, oh yes, I can. Look, we've got the accept header. I can use the accept header to control and vary the response I get from the system when I'm reading it. I can read it using XML. I can read it using JSON. So I know that I have to vary the content type and the accept header during the creation, read, update, probably not the delete process because there's no need to pass in a content type or accept header in the delete. But we can try that too. So header variation, particularly around the content type in the accept header, is going to be very important here. So when I start thinking about what I'm going to do during my testing, those headers are going to be important. If I had started here thinking about endpoints and verbs, it wouldn't be as obvious that the variation in there is necessary. The variation is important here because it's an incredibly important variation that changes. Remember this model? Input, process, output. Those headers are very important for changing the process. They're going to be one of our key variations that we use in the process. So the existing state of the item and the input headers that we pass in. So we're going to add variation in there, which is going to trigger variation over here. And we can see that in the documentation. So this is feeding into my entity model. So I can see here all the fields that we've got. I can see which ones are mandatory, which are not. We're going to explore that in the testing. So it looks like the only one that is not mandatory based on the documentation is the number in stock. So we're going to see what happens when we vary that, when we leave it out. This is the only one then that we possibly can update to null if we can do that. But we're going to explore these different combinations. We can see variation in the output based on the header. And Great, so we've got a list of verbs, but really we're not going to do verb coverage in here. I might choose to get with a head and get without a head just to see what happens. I can see that I can amend in two different ways according to documentation. So we've got post and put. So now I have to map on my state changes. So the update maps onto a post and it can map onto a put. So I have to explore that during my testing. So that's interesting. So now we've learned something about how we're going to approach the testing based on the API. So we've taken a logical model, completely logical model, and we're going to start thinking through how we apply that into the testing. Now, I haven't written anything down, but what I have done is I've built a model, CRUD set of guidelines on paper, and I've expanded the model in my head. And this is what I'm really going to base my testing on, this model in my head. And as I test and as I learn more, that will change the model. And we'll probably do that in the next video rather than this one.